Now that you know how to find the missing sides, we're going to work on finding a missing angle. So given some information, I'm going to label my triangle. I can label it any direction I want. It's always nice to start with that label. Remember, this is side A, this is side B, and this is side C. They're opposite. So I'm going to give you some information. Lowercase a is equal to 5, and lowercase b is equal to 7. So I'm going to go ahead and place those values on this triangle. And b is 7. The question is, how do I find, let's go about and find angle A. So angle A, look at the relationship between 7 and 5. 5 is a side opposite, 7 is a side adjacent. So the only trig function that deals with those sides and has no hypotenuse is the tangent. So the tangent of angle A is equal to TOA, side opposite, over side adjacent. So what I need to do is find A. So this is done on your calculator, and everything in math has an inverse. So that's this symbol right there. That's an inverse symbol, and this happens to be on a trig function. And so what it does is it goes backwards and finds you angle A. So on my calculator, if I want to find that, I can go tangent inverse. So it's the second tangent button. So tangent was the forward button, yellow second tangent is the backward button. And if I divide these two, I can find my angle, and it's approximately 35. Now, WAMAP's going to want you to plug in some extra values there. They're going to want you to plug in at least 4. Let's try this again. I'm just going to keep my triangle labeled as is. So I'm going to call this A, B, C. I'm going to label. Notice again they're lowercase. And this time I tell you B is equal to 8 and lowercase c is equal to 13. So if I find those on my triangle, B is 8 and C is 13. It should make sense that the hypotenuse is longer than the leg 8. And in this case, let's find angle B. That's who I'm going to be looking for. So according to angle B, I know the side opposite, and I know the hypotenuse. So the trig functions that deal, or the trig function, excuse me, that deals with opposite and hypotenuse is the sine. Sine of angle B is a side opposite over the hypotenuse. So again, to undo that word sine, to do its inverse, it's going to be sine inverse of 8 over 13 is going to give me that angle. So on my calculator again, I can find that through the second button. So I go second sine, because I'm undoing it, of the side lengths. And again, I chose the sine because of the relationship of the side lengths to the angle measure. And in this case, I get 37.9799 if I happen to round it. And lastly, let's just try one more. For convenience sake, I'm just going to label it the same way every time. And I always seem to kind of do that. It just helps me along the way. In this case, I know side B is 10, side C is 15. So I'm going to go ahead and place those on the triangle. This side is 10 and this side is 15. And in this case, I want to find angle A. So I look between the 10 and the 15. It should make sense that the hypotenuse is 15. It's longer than the leg B, which is 10. So look at the relationship. So I know I'm going to use SOHCAHTOA. And because I have a hypotenuse, it's narrowed it down to sine or cosine. But according to angle A, I know the side adjacent. So the side adjacent and hypotenuse is cosine. So the cosine of angle A is equal to the side adjacent over the hypotenuse. So once again, I'm going to use my calculator and do the opposite of what I was doing before, called the inverse. And that comes from picking this yellow cosine of 10 divided by 15. And the angle measure is 48.11897 if I round it. A couple things about these right triangles. The largest angle in the right triangle is going to have to be 90. And we talked about that in Discovery 2, where we noticed that all the angles add up to 180. If I have one as 90, I've already taken half of that total sum, so you'll never have an angle in a right triangle bigger than 90.